Let's look at section R.7. Question 1. Use radical notation to rewrite the expression. Simplify if possible. Recall x to the m over n can be rewritten as the nth root of x raised to the m power, or I can rewrite this as the nth root of x raised to the m on the inside of the radical. Either one is equivalent. We can rewrite this as the cube root because that's in the denominator, and the denominator always goes in the index. This is the cube root of 343, and we're going to square the entire expression. We can use our calculators to figure out the cube root of 343, and that is 7. Now we're going to square 7. 7 squared is equivalent to 49. In question 2, perform the operation and simplify the following. We have the square root of 8 times the square root of 32. Recall we have the nth root of a times the nth root of b is the nth root of ab, which means I can multiply the 8 times 32 to one another. This is equivalent to the square root of 8 times 32. 8 times 32 is 256, and we can take the square root of 256. The square root of 256 is equivalent to 16. Question number 3. Write the fourth root of 625 using exponents and evaluate. Let's use the formula for the exponent. And we have this is equivalent to 625 raised to the 1/4 power. There's an invisible exponent of 1 out here, and that's why we have a 1 here. So this is 625 raised to the 1/4 power. Typing that in our calculators, this is equivalent to 5. Question number 4. Write with radicals. Assume that all variables represent positive real numbers. Again, we're going to use our formula that allows me to put this as the index and this as the exponent. This is equivalent to the cube root of 5y plus x raised to the second power, or I can also write this as the cube root of 5y plus x raised to the second power on the inside of that radical. So these are both equivalent. You can choose either one. Example 5, simplify the expression. Let's use 121 and break it down with the factor tree. It's just 11 times 11. And so I can rewrite this as the square root of 11 times b to the 4th times c squared. Now we're looking for groups of 2. The square root of this part is equivalent to 11. Now let's look for groups of 2 in the b and in the c. 4 divided by 2 is equivalent to 2. And 2 divided by 2 is equal to 1. So I have b squared and c. On the outside, there is no remainder. I have a remainder of 0 for each one of these, so there is no radical left. This simplifies to 11b squared c. Question 6. Simplify the expression. Assume all variables represent positive real numbers. We're going to do a similar technique to example 5. Let's break down 252. It ends in a 2, so let's take out a 2. And that's 2 times 126. Again, I'm going to take out a 2. 2 times 63 gives us 126. Let's take out a 3. 3 times 21, and then 21 is 3 times 7. This can be rewritten as 2 times 2 times 3 times 3 times 7. If you're not sure, double check this with a calculator, make sure it's right. And we have also x to the 6th, y to the 15th in the radical. Now we're looking for groups of 2. Groups of 2. This is a pair of 2. This is a pair of 3's. And we have 2 times 3 in the front. The square root of this is 2. The square root of this is 3. We have a 7 left on the inside. And I'm going to divide that 6 by 2 because 2 is in the index. 6 divided by 2 equals 3. No remainder. So we're going to have x cubed on the outside. And 15, I'm going to divide that by 2. That is 7, remainder 1. So I have y to the 7 with 1 y left on the inside. And we can simplify this as 2 times 3, which is 6x cubed, y to the 7th, times the square root of 7y. Question 7. Simplify the expression. Assume all variables represent positive real numbers. Recall the nth root of a over b is equivalent to the nth root of a divided by the nth root of b, which means I could take the square root of each of the terms. Let's rewrite this as the square root of x to the 5th, y to the 7th, divided by the square root of z squared. Now we're looking for groups of 2. 5 divided by 2 is 2, remainder 1. 7 divided by 2 is 3, remainder 1. 2 divided by 2 is 1, remainder 0. That tells me I have an x squared on the outside with 1x left on the inside. For the y, we have y cubed with a remainder of 1, so that's y on the inside. Now in the denominator, the square root of z squared, that's equivalent to z. There is no remainder, so there's no radical. And there's no possible way to simplify this. We are done with number 7. Question 8. Let's simplify the expression again. I'm going to break down the 8 and the 32. 8 is 2 times 4. 4 is 2 times 2. 32 is equivalent to 2 times 16, 2 times 8, 2 times 4, and 2 times 2. Let's rewrite this as 4 square root of 2x minus the square root of 2 times 2 times 2 times x plus the square root of 2 times 2 times 2 times 2. There should be 5 2's and an x. We're looking for groups of 2 because this has an index of 2. This has a pair of 2's. This is a pair of 2. This is a pair of 2. That's the only groups of 2 that we have. I can rewrite this as 4 times the square root of 2x minus the square root of 2 times 2 is 2. And inside we have 2x. We have the square root of 2 times 2 gives me the 4 in the front. And inside is 2x. Since they have the same radicand and the same index, we can add the coefficients in the front. We know 4 minus 2 plus 4 is equivalent to 6. So our solution is 6 root 2x. Question 9. Let's simplify the expression. This is a cube root symbol, so we're looking for groups of 3. 16 is equivalent to 4 times 4, and we have 2 times 2 for each of those 4's. 128. 128 is 2 times 64. 64 is 2 times 32. And 32 is 2 times 16. 16 is 2 times 8. 2 times 4. And 2 times 2. So 128 has a lot of 2's in it. It has 1, 2, 3, 4, 5, 6, 7 2's in it. I can rewrite this as 9 cube root of 2 plus 5 cube root. 16 has 4 2's in it. And 128 has 7 2's in it. 1, 2, 3, 4, 5, 6, 7. Now we're looking for groups of 3. This is a group of 3. This is a group of 3. And this is a group of 3. This is equivalent to 9 times the cube root of 2 plus. Now we have a group of 3 here, and we're going to have to multiply it with the 5 in the front. This is 2 times 5 cube root of 2. There are 2 groups of 2, so we'll multiply to the front 2 times 2 for each of the groups. Now there's a negative here, so let's make sure we have a negative. And this is the cube root of 2. Since they have the same radicand, the same index, we can actually add all of these up. But before we do that, let's simplify the coefficients in front. This is equivalent to 10 cube root of 2. This is equivalent to negative 4 cube root of 2. And now we can collect like terms. 9 plus 10 is 19. Minus 4, that's 15. This is 15 cube root of 2. Question 10. I am going to FOIL this question out. 7 times 3 is 21. We have root 3 times root 7. That's the same thing as the square root of 21. That's the very first multiplication. We multiplied 7 root 3 times 3 root 7. Now we're going to multiply 7 times this invisible negative 1. That's negative 7. And we have root 3 times root 3. That's root 9. We're going to multiply root 7 times 3 root 7. There's an invisible 1 here. That is equivalent to 3. 1 times 3 is 3. And root 7 times root 7 is root 49. We have 1 times negative 1, that's negative 1. And root 7 times root 3 is root 21. Let's simplify some of these. This is 21 root 21. Root 9 is 3. And root 49 is 7. Now let's collect like terms. We have 21 root 21 minus 1 root 21. That is 20 root 21. Again, we're just looking at the coefficients in front and keeping the same radical. Negative 7 times 3 is negative 21. And 3 times 7 is positive 21. Notice these two cancel out, and my final solution is 20 root 21. Question 11. Rationalize the denominator. When you see rationalize the denominator and there is a binomial in the denominator, use the conjugate. Remember, the conjugate is exactly the same as the binomial, except the sign is different. This is a plus, so this sign has to be a negative. We're going to multiply by root 13 minus root 6. Since I multiply that to the bottom, I have to multiply the same thing on the top. This simplifies as root 6 times root 13. And root 6 times root 13 is root 78. Minus root 6 times root 6 is root 36. Now I could definitely FOIL the bottom, but I don't have to because this is the difference of squares. Recall a squared minus b squared is a minus b times a plus b. So we could use this formula instead. So I can say this is equivalent to the square root of 13 squared minus the square root of 6 squared. I can't simplify the square root of 78, so we'll leave that alone. I know the square root of 36 is 6. The square root of 13 squared, that's 13. The square root of 6 squared, that's 6. And now we can simplify the denominator. 13 minus 6, that is 7. And we can't seem to reduce it any further than that. That's our solution. For question 12, we want to use the wind chill temperature given by this formula. And all I really need to do is plug in the T being equal to 10 here and here, and plugging in 30 into the V here and here. So this is a 100% calculator question. So double check with me that you get the same number on your calculator. So plugging in all of this into our calculators, we want to plug in 3.87 plus 0.6229 times 10 minus 35.32 times 30 raised to the 0.16 power plus 0.9036 times 10 times 30 raised to the 0.16 power again. So enter all of this on your calculator. Make sure you have those parentheses and those carets for the exponents. And so this is equivalent to negative 3.20 degrees. We have a wind chill of negative 3.20 degrees. Example 13, simplify the expression. Let's break down this using the formula. The nth root of a divided by the nth root of b is equivalent to the nth root of a over b. So let's use that for this part here. I can rewrite this as the 6th root of 16 over 8 times the 6th root of 32. 16 divided by 8, that's 2. This is equivalent to the 6th root of 2 times the 6th root of 32, which I know is 5 2's. I'm looking for groups of 6. In this case, we have 1, 2, 3, 4, 5 2's. There's not enough, but I can multiply this, and recall that if I multiply two radicals with the same index, we can combine it into one big radical. This is equivalent to the 6th root of 6 2's now. And so this is a group of 6, and our solution is 2. What do you know? Our solution is 2.